Let's talk to James Head, who's Professor of Geological Sciences at Brown University. Good to see you, Professor. Welcome back to the programme. So explain to us how this satellite's going to work. What will it allow that it isn't currently possible?
Well, you know, when the Apollo astronauts went to the moon, I worked in that program, and basically, when Dave Scott came back from the moon, he told me that when they went around to the far side, you couldn't see the Earth, you couldn't see the sun, and the only way you knew the moon was there was there was a place with no stars. That's what it's like to be on the far side. So you need something in higher orbit to be able to communicate from the far side back to the Earth. That's totally essential, and we just know so little about the far side. So essentially, Queqiao-2 will enable us, as with the first satellite, to be able to communicate with the far side. With Chang'e-4, the rover, you can see the little rover here in the corner here, that was able to be worked on the far side by having that first satellite. This will be even better because it's larger, it's more capable, and it will begin the constellation of communication satellites that China is putting in orbit. And for a scientist, it enables us to communicate with the far side lander Chang'e-6, and then Chang'e-7 and 7 and 8, and the International Lunar Research Station. So it's very exciting from a technological and a scientific point of view.
So how much is there to learn about the other side of the moon? What can it tell us?
Well, it's very different than the near side, and we don't really understand why that is. I just gave a paper in Houston, Texas, at our major conference on some of the ideas about why the sides are different. And also, we really need to be able to collect samples from there, which Chang'e-6 will do when it's launching in May. And the key here is about the moon is we don't really understand exactly how it relates to the Earth. We know that a big impact in very early Earth history, a Mars-sized object hit the Earth, ejected material, and that formed the moon. And if I want to understand how, you know, anybody, what their behavior is like, you really need to understand their childhood, their formative years. And that's a big event in the childhood of the Earth and the moon system. So if we don't understand the moon, we really don't even understand our home planet Earth. So it's critically important to explore the moon and the far side and all the moon.
And China in particular has big plans to explore the moon, doesn't it? It's hoping to land astronauts there in 2030. What difference will this satellite make as part of those plans?
Well, it'll be really incredible for increasing communication. So one of the other problems we have, besides the far side communication, is all the data we want to bring back. Now we have much more data capability to send back many bits of data. And so we need sophisticated communication in order to enable that data to come back digitally in real time. We want to see what the astronauts are doing on the surface, the taikonauts, the astronauts, etc. We want to be able to get tons of data to help support them on the surface, and that's what this communication satellite, as well as a constellation of satellites, will really enable us to do. It's a really remarkable achievement on the part of China, and it'll help with international exploration as well.
So this is a particular push by China, but do you think we're actually now entering a new era of moon landings more broadly?
Oh, absolutely. It's just stunning to me, having worked in the Apollo program, to see lunar missions by the U.S., by China, by ESA, by Japan, India, Russia. Korea just launched one, United Arab Republics, Israel, and even private companies now. So it's really an international destination. It's like Antarctica in the sense that it's an international activity. The scientists are really trying to understand how the moon formed and how it's related to the Earth. And then we contribute and pool all our data to try to develop an international understanding of this.
Professor, great to talk to you as always. Thank you for joining us. That's Professor James Head from Brown University.
My pleasure. Thank you.